everyone. I'm Dr. Caroline Johnson Barkjohn. I'm a physical scientist at the United States Environmental Protection Agency's Office of Research and Development. I'm here to talk to you about our paper in atmospheric measurement techniques, development and application of a United States-wide correction for PM2.5 data collected with the Purple Air sensor. Air sensors are becoming more and more widely used across the United States and around the world. Because they are small, portable, and relatively inexpensive, they can provide communities with data in locations that do not currently have any air quality measurements. Despite their convenience, it can be challenging to compare sensor data to other networks of air quality data because sensor data can be noisy with random spikes in concentrations that may not be due to true pollution events, and sensor data can have systematic biases and inaccuracies. In this paper, we attempt to answer some very important questions, including how can we clean noisy sensor data, and can the systematic biases from sensors be corrected? In this work, we partnered with state, local, and tribal air monitoring agencies to obtain air quality data from Purple Air sensors that were co-located with regulatory air monitors across the United States. We were able to analyze the data and build a nationwide correction equation for PM2.5 data from the Purple Air sensors. Having accurate PM2.5 data is important because it can be used to inform actions to reduce exposure and limit the harmful effects of PM2.5. Here's the US-wide correction equation that we built. Although numerous corrections have been developed for the Purple Air in the past studies, our equation was built on a national scale, incorporating data collected in many different regions of the United States. Our correction provides the first test of whether a single correction can produce reasonable agreement with regulatory data across the United States. The equation includes a relative humidity term as measured by the Purple Air sensors, which reduces bias across parts of the country that are wetter or drier. We also propose additional data cleaning steps that improve accuracy. Namely, Purple Air sensors have duplicate Plantower PM2.5 sensors inside, and only when these two Plantower sensors reported similar concentrations were they considered to have high enough confidence to be included in our analysis. This correction, along with the proposed data cleaning steps, are currently in use on the AirNow fire and smoke map, where sensor measurements fill in some of the gaps between permanent and temporary regulatory quality monitors. Here is the AirNow fire and smoke map, with the Purple Air sensors represented as squares. These methods of data cleaning and correction have the potential to provide individuals and communities with higher quality sensor data for use in a variety of air quality and public health applications. I hope you'll check out our paper where you can find many more details on the correction equation, how we built and evaluated it, and the recommended data cleaning steps. I'd like to thank my co-authors in this paper, Andrea Clements and Brett Gant. Also, this work would not have been possible without the state, local, and tribal air monitoring agencies and other organizations who co-located these sensors and provided us with the data. Thank you so much for partnering with us on this project. Lastly, the views expressed in this video are my own and do not necessarily reflect the views and policies of the US EPA. The mention of trade names does not imply endorsement. Thanks for listening.